Okay, the next part of your lab is we're going to talk about some pre-lab questions based off of the information that you watched in the background. Okay, this is an important feature. So as we move through the lab, we kind of understand what we're trying to do. Okay, so the first question that I want us to think about is drawing a lattice structure involving magnesium and chlorine. So in the background, I gave you an example of sodium and chlorine, and we know that sodium and chlorine are a 1-to-1 ratio because their charge is both 1. Now, if we're looking at this example, our charges are no longer just 1, right? We have magnesium with +2 and chlorine with -1. So we ask ourselves, do the charges cancel? The answer is no. So therefore, we crisscross their charges, which means this formula comes out to MgCl2, which means for every 1 magnesium, I need 2 chlorines. So the difference in this structure than the one that we looked at in the background is that you're going to see 2 chlorines for every 1 magnesium, okay? So I want you to take a gander at this. This is magnesium chloride. Again, for every 1 magnesium, I have 2 chlorines. For every 1 magnesium, I have 2 chlorines, right? For every 1 magnesium. So anytime you have an ionic compound that is a lattice structure, the lattice structure is going to be the ratio between the metal and the nonmetal. Okay, so that's the first question. The second question, we're going to discuss polar and nonpolar, okay? Polar and nonpolar molecules are based on their difference in electronegativity rules, which is what I explained in the pre-lab. Based on this knowledge, let's do some research as to why are CH bonds considered nonpolar, right? Because if you remember in the background, I said they're different atoms, they're going to have different electronegativities, and one would think that they would always be polar, okay? But in this case, if the electronegativity differences aren't that large, then the bond is going to act like a non-polar bond. Okay. And then the second part is we're going to say which is more polar, OH or NH. Okay, so the first question, let's look at it. Carbon has an electronegativity value, and remember, we can look at our periodic table to figure this out, or we can Google it. Carbon's electronegativity is 2.55, where hydrogen's electronegativity is 2.20, which indicates that their difference is 0.35, which means that one element does not want the electrons more than the other electron or than the other element. So therefore, they are going to share evenly or equally their electrons. So that indicates this is a non-polar bond. The second one is now we have to compare oxygen and nitrogen, right? Because they're both bonded to hydrogen. So we know hydrogen's electronegativity is 2.20, right? So really we just have to consider who has the higher electronegativity, oxygen or nitrogen. If I look up their values, oxygen has an electronegativity of 3.44, nitrogen has an electronegativity of 3.04. So since oxygen's electronegativity is higher, that means that it's going to have a more polar bond, meaning oxygen wants the electron from hydrogen more than nitrogen wants the electron from hydrogen. So that bond would be considered more polar. That's question 2. Question 3. The three-dimensional structure of diamond is shown below. Use the structure to explain why diamond is the hardest known metal or material. What kind of solid is this? Okay, so we see covalent bonds happening, and like we talked about in the background, it's kind of forming like this really rigid structure, right? So since those covalent bonds are forming with each other and they're making themselves bigger and their strength is going to increase. So diamond structure is built using strong bonds between each carbon molecule, which becomes very difficult to break. This is considered a covalent network. Question number 4. This is the last pre-lab question, I think. In order for a substance to conduct electricity, it must have free moving charged particles, okay? Use the model of metallic bonding to explain why metals conduct electricity, okay? Well, we kind of talked about this a little bit in the background, but let's look at a better picture. What ends up happening, you'll see that these electrons are not evenly dispersed here, right? I have an electron up here, I have an electron here, I have electrons moving down here. What that is indicating is that those electrons are kind of moving through the metal, okay? Since they are free moving, I can hook something up. I can hook a wire up to this, right? And those electrons will be able to move through that wire and to conduct electricity. That is why when we do electricity, we use copper wire, right? because the electrons can move freely from one side to the other. And that is how we get electricity, is because of the movement of electrons. Okay, that's it. Thank you. Next part is the procedure.